Well, hello, everyone. Thank you for attending today's webinar, What's Inside Indoor Mapping Applications and Best Practices. My name is Amy, and I'm the Operations Manager here at National States Geographic Information Council. If you are unfamiliar with our organization, NSGIC exists to advance effective national coordination of geospatial information by supporting state-level cooperation. We serve as a national forum for the development of capable and future-oriented geospatial leadership. If you'd like to know more information on how to get involved, please visit our website, www.nisgic.org. Some reminders for our call today. All attendees have been muted on entrance. There will be time at the end of the presentation for Q&A, so please place your questions into the chat box. They will be answered in the chat box and be read aloud at the end of the presentation. Additionally, a recorded version of this webinar will be made available afterwards, so be on the lookout for that information. And with that, I will now turn it over to the presenters. Thank you again for joining us.
Thanks, Amy. Welcome to our presentation and our discussion on indoor mapping applications and best practices. My name is Ashley Buzzio. I lead the development and growth of our SaaS-based solutions here at Michael Baker International as part of our DataMark team. I'm incredibly passionate about GIS and geospatial technologies in general, and have really built my career on continuing to innovate and really find solutions where GIS can help solve. With me today, also from Michael Baker, are Jessica Chambers and Matt Vandenville. Jessica?
Sure. Hi, everyone. My audio is working before. Can you guys hear me?
Yes.
Okay, great. So I'm Jessica Chambers. I am the Director of Engineering and Design Technologies here at Michael Baker. What that means is I am responsible for managing Michael Baker's extensive technology stack for the production of our AEC services and solution offerings. What that also means is I am not a GIS professional. So this is all very new to me. This audience is a little nerve-wracking because I know you're all very intelligent, but my background is predominantly in BIM and VDC. And as we go through the presentation, you'll see how these two worlds are colliding, not only in the industry, but also here within Michael Baker. So I'm very excited to be here. Please forgive me with any lack of or incorrect usage of GIS terminology. I am still learning here, but I am very excited about what these two worlds have to offer with respect to indoor mapping. I'll hand it over to Matt.
Yeah, my name's Matt Donenville. And I recently joined Michael Baker and DataMark from Esri as the 3D tech lead, and at DataMark here, the product owner of indoor mapping. My interests and a lot of the R&D that I've worked on and the projects that I've worked on in the past include anything 3D and digital twins, indoors, Esri's IPS solution, and then with a background in data science and reality capture.
Awesome. Thanks, Jess. Thanks, Matt. So a little bit about who we are before we jump into talking all things indoor mapping. So for over 80 years, Michael Baker International has been a leader in engineering and infrastructure. We're headquartered in Pittsburgh and have nearly 100 offices nationwide. Over 200 geospatial professionals at our fingertips, and 3,500 planners, engineers, architects, construction managers, technologists. And we really value our partnerships in the indoor mapping space with companies leading in this space, Autodesk, Bentley Enterprise, Esri, and AWS. Jess, Matt and I are part of what's called Consulting and Technology Solutions team, where we provide a whole host of the latest technologies for our services to tackle various, project challenges. I'm going to share just a few examples of what the verticals that fall under the CTS group include. So our aerial technologies team was one of the first in the engineering industry to receive certification from the FAA to operate various types of fixed wing and vertical takeoff and landing UAS. We continue to pioneer UAS in inspection and survey work, and our UAS pilots are licensed engineers and surveyors who create orthophotos, 3D models, to support engineering projects and offer services in the spaces of, law enforcement, emergency response, aerial inspection and mapping, among others. Our broadband services and team supports all levels of government and community organizations through broadband projects for identification, access to funding, and initiatives that are really designed to provide affordable and equitable access to broadband and related digital services. Datamark is our public safety GIS team that provides SaaS-based solutions. For example, in the Next Gen 911 GIS maintenance and aggregation space. We also offer end-to-end services from assessments, strategic planning, long-term data remediation, and maintenance of GIS data. Our geospatial services group provides geospatial solutions to both public and private sector clients. We're doing all things, strategic planning based on production methodologies, quality control, and also forming lots of collaborative partnerships throughout that, addressing the entire life cycle of critical infrastructure projects and supporting everything from conceptual planning, surveying, design, construction, all while leveraging big data. And lastly, the one I'll talk about is our pavement collection. Our LiDAR solutions, we're using remote sensing technology to collect exacting information on roadways, airports, bridges, utilities, rail transit systems, really to support planning, engineering design, and smart vehicle technology. In terms of pavement, we're providing a full range of pavement engineering and management services using technology-first services for pavement data collection, assessment, design, and implementation. So that was a mouthful. We do a lot, and I didn't even cover everything, right, that falls in our CTS group. But the point is, we're putting technology first in all of these offerings. And what we're really here today is to focus on indoor mapping and all of our indoor mapping efforts, which actually span quite a few of those solutions that I just shared. So today we're really excited to talk about the importance of indoor mapping and the tools and offerings that are available today to support the market in indoor mapping space. We're going to talk about current uses of indoor mapping and the emerging and future uses. And then towards the end, we'll talk about some best practices in indoor mapping creation and conversion, as well as work to build up our uses and repositories of indoor mapping and geospatial data.
Fantastic. So start. I'm getting really bad feedback, so I'm going to try and power through this, everybody. So before we start, we definitely have a few thoughts on this space. Historically, BIM, CAD, and GIS have been running on these parallel tracks in the industry, right? So CAD is being that digitized pen to paper environment where we're creating digital plan sets, digital 2D information, BIM being the progression of CAD in that space, building information modeling where we're generating information embedded into three-dimensional models, and GIS, all of you know what GIS is, but that geospatial relationship of that information to our environments, right? So historically, we have had these GIS tracks, we have had CAD tracks, we've had these BIM tracks. What's exciting right now is that we have the convergence of all of this data, right? So everybody's heard of big data. Everybody has heard of this information getting generated in all of these different areas. And what's really exciting is we now have the capabilities to bring that data together, okay, and start analyzing it in these through these different lenses. One of these lenses and where we want to head and what's possible with all of this data converging is the development of digital twins. Okay, so digital twins are those virtual representations of a physical asset or a physical piece of the built environment. Digital twins can really be anything. So we can talk about it with respect to buildings, we can talk about it with respect to infrastructure, but it does become very powerful as we bring all of this information together from all of these different sources. Indoors is a very a very powerful tool when it comes to digital twins. So indoor mapping, which is something Baker has been doing for quite a long time, and Baker has also been designing in BIM and CAD for a very long time. Bringing those two data sources together as we press forward with the development of digital twins is really this exciting space that we're working diligently to progress. So indoor mapping is really that area that we are looking to progress in that we want to leverage all of this BIM data coming together. We want to leverage CAD data to make our indoor mapping solutions and environments much more powerful. So Ashley, we're gonna go, there we go, awesome. So what is indoor mapping, right? So again, I'm not a GIS expert on this call, but I think it's important for the GISPs to hear this outsider's perspective. So indoor mapping is definitely one area that being a BIM and VDC professional, I can wrap my head around. It's a scalable solution that helps create that virtual indoor environment. And where I really love 3D models and all of the information contained within them, I have to really understand that this also contains the consumable nature of this data as well. So indoor mapping can take all of that very rich data that we have generated throughout the design process and embed it into a very consumable nature with respect to indoor mapping. This can include those two-dimensional drawings that are produced in CAD or even in PDF or even scanned to PDF from a drawn perspective. It can include those three-dimensional models, whether they are intelligent or not. It can also include those 360 Matterport immersive environments with point clouds or photogrammetry. So that indoor mapping really generates that consumable nature of that data in an environment that's understandable for users of some very complex data. What we can do with all of this data is inform ourselves on making these decisions, right? So data-driven decisions with respect to the different various indoor mapping applications. We can create this space or put a lens on indoor mapping to create a common operating environment. We can use this for navigation and wayfinding and also managing the assets that are generated throughout design processes or captured during an indoor mapping data collection firm. Some of the things that Baker's really good at is that we are that AEC firm, right? We have been operating in this space for quite some time. We've generated a lot of this two-dimensional and three-dimensional engineering drawings, architectural models, 3D photogrammetry capture and LiDAR, and we've produced custom applications surrounding how to support and view all of that information. So with this consumable environment with ArcGIS indoors and indoor mapping, we can now integrate all of that data we've been generating over the years and then provide with BIM experts and CAD experts into this space. So now we're going to jump into the applications of the different applications we can use for indoor mapping. So as you can imagine, with all of this data, all of these different lenses and all of these spaces, there's a lot of different opportunities for indoor mapping to tackle. Michael Baker's data mark, where Ashley and Matt operate predominantly, has really established itself in this public safety arena for indoor mapping. We offer those tiers of solutions, anything from digitizing floor plans and routing, asset tracking, and rapid response information. But this is a very much an emerging market. So this particular slide starts categorizing the general areas where indoor mapping is used. We have current and emerging applications and business cases in this space. And when I mean current, what I mean there is that this is really a well-established indoor mapping application. This is repeatable across multiple firms. This is, best practices established, and we're leveraging routine sources of data to produce these outputs. The emerging space is where we're still kind of testing, right? So some organizations have established and produced an offering out in the market, but others are still, including Baker in some of these spaces, really identifying what data comes from where in order to generate these offerings. So some of the well-established markets include the space planning and redesign, asset inventory, the wayfinding, as well as event planning. We don't need a whole lot of BIM data coming from these sources, but we do want to we can generate these from existing information, from two-dimensional or from just information sources within GIS. But BIM makes it very powerful, right? So these are areas that we can still advance with. And then some of the emerging areas that we have here are public safety, the due diligence. So surrounding due diligence is really a lot of the ability to simulate or forecast based on existing environments. Industrial design, is another area where we want to produce data to really rapidly develop our design and construction plan. So using that GIS information and that very consumable format to better inform our future designs and space usage. Cellular design and audit. This is a huge piece that is being established to not only track how spaces are used, but also gather data around occupancy, temperature, and locations of people within a certain space. So we're going to dive deeper into a couple of these applications here.
So in terms of public safety, according to our pretty well-established public safety customer base, about 70% of incidents requiring emergency response happens indoors. And yet the problem here is that access to indoor location information is just largely unavailable, or it's just wildly out of date. And that can be a challenge, right? When we need to have this information at our fingertips. Challenges without having really accurate, up-to-date indoor mapping information, right? We get a lack of situational awareness. When precious seconds are paramount to response times, right? Building occupants can have difficulty locating key assets, like where is the closest AED, or where is the closest fire extinguisher, or even fire exit, for exit routing, for whether it's occupants or first responders trying to find, those accurate closest exits or entrances. So our focus really in this space is to support public safety entities in moving away from no data, outdated data, or even inaccessible data that does exist, to having robust indoor mapping data and solutions that also allow them to improve their situational awareness, make sure that the knowledge of all of those important assets and the information about those assets is at their fingertips. And then also a way to keep the information up to date and current, which is a really, really important piece of this puzzle, right? We can create all the indoor mapping data that we want, but we have to make sure that it doesn't sit stagnant, and we know that spaces change quite frequently.
All right. Space planning and tracking are really two areas that can be fully sustained with indoor geospatial data, but become very, very powerful when coupled with with BIM data generating from design and construction processes. So with space utilization, indoor mapping can be used to assess the effectiveness of how a space is utilized. This can be really as simple as leveraging Revit room tags to communicate the space's design intention, but also as complex as extracting sensor data to determine how frequently spaces are occupied, accessed, or connected to a Wi-Fi, right? So during design, architects, and just to give you a little bit of background with respect to the Revit environment, architects must comply with occupancy standards, right? And that information is embedded within our BIM models. We have occupancy standards that are being demonstrated with respect to our specifications, our FF&E. And what that means is that we can then collect that data that exists within that Revit model and populate it within a GIS environment. So there are some standards and tools that are surrounding this, in the marketplace and Esri offerings, as well as Autodesk, the preparation of that data into IFC and ISO 19650 standards. But this is where one of those really powerful powerful connections exists. We get a lot more information instead of just seeing what a room's name is. We can go beyond and see how that room is actually being used, or that space is actually being used. On the asset tracking side, this is where we get down into a much more confined space with respect to individual assets. So when our teams are moving forward with the development of a new particular project, we want to see things about, when do assets need to be replaced, right? We want to understand how those assets are being used. I worked on a project not too long ago where we were redeveloping and renovating a factory floor, right? And so as part of that project, we had to collect a lot of information surrounding the performance of particular assets that help this factory make money. That included creating that virtual environment, right? So maybe before I didn't call that indoor mapping, but generally where we were headed with that particular project is we're capturing all of this information, we're collecting the asset information, we're connecting that asset into that BIM model. And then creating a lens in order to visualize and obtain information about how those assets are being used. Additional asset tracking could literally be tracking an asset, right? We have a lot of spaces where we have movable and malleable functions of those particular spaces. We have equipment moving through those spaces, and we need to be able to identify where those spaces are in real time. And indoor mapping and provides that, again, that lens and that environment for us to track those particular assets.
Oh, for another kind of what Jessica was elaborating on the real-time asset, the human assets, and we kind of take this take the advantage of this with outdoor mapping from any provider having the blue dot, and that's really GPS based, but we can't get GPS inside a building. And to be able to perform a lot of these different use cases, there's varying levels of accuracy that are needed. There is a little bit of native phone-based triangulation inside of a indoor space that can get general approximation. And obviously that's the cheapest way. That people have phones, there's no extra hardware. But as we experience or dive into some of these other use cases, we realize that supplementing kind of cellular and GSM precision with Wi-Fi, Bluetooth low energy, and ultra wideband can enable different use cases. Things kind of, especially in the Z axis, where the triangulation of GPS and cell phones aren't as robust, often augmenting with the Wi-Fi or the Bluetooth low energy to get the precise Z elevation is really critical, especially for things like public safety, where a first responder might need to know what level a person is on, or even customer engagement, where the customer needs to know if they're on the second floor of a mall or first floor of a mall, because the businesses are completely different. Different areas that use this a lot of customer engagement, public safety. It's really important to have a more precise location. But like Jessica was talking, asset tracking. So real-time feeds of assets, whether it be in forklifts and warehouses to look for collision or human assets or beds in a hospital. Wayfinding on top of an indoors map is very important. That's also kind of a cost benefit a lot with what investment of building hardware is needed. Not every single building can justify putting in infrastructure to get really precise location. They might not have that use case. This extends into event planning and kind of reservation systems. A lot of people probably on this call have been to conferences with a PDF map, and when people go to conferences or large events, it's often in a new space they're not familiar with. Try to navigate that. So that's kind of in that customer experience as a customer of a conference or event, but can also be enabled through routing to sessions or to meet up with different people you're supposed to meet. So maybe a customer support advocate that you've never met in person, but actually getting to meet with them. And then also aided by some integrations like Office 365 scheduling and different third-party integrations to make kind of seamless user interactions.
All right. Well, thanks, Jess. Thanks, Matt. We just kind of covered talking about different applications of potential indoor mapping and how they fit into public safety and wayfinding and asset management, facilities management, conference scheduling. We want to move in now to talking about some best practices in indoor mapping data efforts for geospatial source data. But also for the consumption of that data. And then we're going to provide at the end some additional considerations. So we've identified several sources, right, of indoor data that we can either go out and gather or find these sources because it exists. And so we want to talk through each of these that we've listed here. We've included BIM, CAD, paper blueprints, a term that is somewhat new to me that I've been hearing a lot in the market called a principles map, which really is, hand-drawn maps, right? Something that you've hand sketched and identified what that indoor space sort of looks like. And so, and then the last one there that we're going to talk a little bit about is when you have nothing. What do you do? How do you create some indoor data when there isn't anything available? So Jessica is going to start with talking about BIM data, or building information modeling, which really is a holistic process of creating and managing information for built assets. So in other words, it's embedding valuable information into a 3D model that's leveraged throughout a project lifecycle.
Fantastic. So BIM to GIS for you is likely as challenging as GIS is for me. Okay, so bear with me. BIM is also a very valuable and powerful data source. Okay, so we're going to start with understanding where the data comes from and how it's created. Predominantly, we'll use Revit as a source to populate BIM data into ArcGIS and doors. All right, that's where the information comes from. So a little bit behind the curtain with respect to Revit data creation is Revit creates three-dimensional objects on a screen in space, and it's a virtual model. Okay, within those assets, we do have attributes associated with them. This can be generated from what we call families. Okay, so families of information. This can contain information surrounding about how a component is put together. It can be as detailed as from a manufacturer, like for example, if you have appliances or kitchen cabinets, we can get down to information about the material of those cabinets, the manufacturer, the finish on those cabinets, and how they are assembled, the hardware necessary for it. This data is generated usually manually. Sometimes it comes from a marketplace and it's populated into your model. Those models can then leverage that data to do things like create bill of materials for procuring that information. It can be used for substitutions or connecting to a specification environment. So it's a really powerful data source, right? The problem with BIM data is it's not always been standardized, okay? So the standardization of BIM data has been traditionally at the responsibility of the creators. Okay, so the creators of BIM data are design firms, engineering firms, and architectural firms. And I don't know if you've met an architect or an engineer, but they like to own a lot of their information, right? So they want to make it the standardization surrounding that information very much up to themselves. They develop their own organizational standard, and then that standard is used and rinsed and repeated for when they produce their models, their projects, and construction plans. As BIM has continued to evolve, and we have the UK and the rest of the world to thank for this, there have been standards saying like, okay, so now we're delivering this Revit model to a contractor, and they're getting 35 different models from 35 different organizations using 35 different standards. It has to stop. We need to have a BIM standard. This is where we get ISO 19650 from. Okay, this is also where we start to see things like COBE and IFC as capturing the data from the BIM model to be used in construction or beyond. This is where we're starting our conversation with respect to indoors. Okay, so having BIM standards from an organization isn't enough. We have to make sure it is in some type of standardized format to translate the information efficiently from BIM into an ArcGIS indoors environment. So in the marketplace right now, we have seen Autodesk come out with a connector. This connector produces and connects IFC data into an ArcGIS indoors environment. We've also seen that from the other side of the equation, right? So this is where Esri has produced tools in order to extract information from a BIM model into an indoors environment. So it's so great that we're working on this. It's really evolving quite well, but you have to be cognizant that you can't just take some willy-nilly standard and try to use these tools effectively. So additionally in here, BIM isn't just about Revit, right? Okay, so I'll be the first one to preach about that. BIM is also coming from any type of information that is putting together basically collecting data surrounding that built environment and producing a level of accuracy and whatnot. So we can use additional sources in that BIM space. We can geo-reference those sources. A lot of them have location information on that. We have the ability to reference information that's not necessarily generated in the three-dimensional objects, but also the annotations that we're creating out of Revit or Civil 3D or Open Roads or any other design application. We are also using, in this translation to a geospatial environment, we do have to do some type of translation at times. Our civil engineers are designing with coordinate systems in mind. I know that's a very common area of expertise with GIS professionals, but with architects, they don't really care often about those coordinate systems. So they have relative coordinate systems with respect to their buildings, and they want to, so we do have to do some preparation surrounding making sure that all of these pieces and parts are connected from a data perspective, so we can geolocate them appropriately into an indoor environment. So I saw a question pop up in that chat there too about the role of the Autodesk connector. So Autodesk connector is connecting BIM data into a GIS environment. So think of Autodesk connector as going this way, and think of the ArcGIS Pro Tools going the other way. They're capturing that BIM data from Esri into the ArcGIS indoors environment, whereas the Autodesk connector is pushing that information into the ArcGIS indoors environment. Okay, so there are two things doing relatively the same piece. One is coming from the Autodesk world, basically an architect wanting to push that data into an environment. And the other one is coming from the Esri world.
Awesome.
All right, so I'm gonna move on.
All right, so the second source of indoor data we're going to talk about that Matt will talk about is CAD, so computer aided design, as a source of indoor mapping data. CAD systems are really used to capture, create, design blueprints containing, right, geometric wireframes, attributes, styling information, and the like. So Matt?
Sure. So I think CAD is probably a familiar term even for GIS professionals. Anyone that's built a house or pretty much most buildings, even before CAD on a computer, there was blueprints. So people are pretty familiar with what CAD is, and it's really the most authoritative part of an indoors model. But that doesn't necessarily mean that it's the easiest. We'll talk some of these other ones. BIM is obviously newer with newer projects are using BIM, and there's a lot more information inside of that. So that's for the newer projects. But since CAD covers kind of the broad range of buildings, it's what we see the most of. And when I say it's not necessarily the best all the time, it's because there's good and bad CAD data. And that comes down to how it's drawn. And really what Jessica was talking about, even with BIM, is there needs to be standards, CAD standards, BIM standards. There are conversion tools that we use that ArcGIS has that converts the BIM and the CAD, but you need to get it into a workable format first. And by workable format, I mean things labeled properly, rooms and areas set. Some big ones that people can usually relate to, even if they're not really experienced with CAD, is the manual drawing of a door versus using a standard door symbology, or someone not having drawn the architectural wall, the outside wall, all the way to the corner and actually snapping it. And so there's these voids. And that really causes some havoc with kind of the automatic ingest tools. So it can take something that's a 5-minute automatic ingest and really scale it out. And when we talk about scalability later, that can really cause some problems. So good versus bad CAD data, it's definitely not all equal, and it's a big consideration. But if the organization is living by some standards that can be deciphered, it can be as easy as doing some basic mapping of CAD layers to the indoors data model on a single level of a building, and then extrapolating that and automatically importing hundreds of buildings. So the key, and kind of one of the takeaways that you guys will come away with for this whole presentation, is the key of these standards and kind of the importance to make indoor mapping really attainable on a large scale.
Absolutely. So next we're going to talk about paper blueprints, right? These are sources of indoor data that are paper drawings or plans, and they may exist maybe as your only option, right, of some sort of reference of what that inside space might be. So in talking about paper blueprints, right, it's pretty easy to take a paper blueprint, a paper copy of a plan, and take it, scan it in to make it digital, georeference it to space, and then go through the process, right, of digitizing the information you want to collect from that plan. And so the idea is to take it from paper to digital, and then from digital to geospatial in terms of geospatial data layers, right, or information about that space. So it's really also important to understand the type of blueprint that you're working with, because if you're working with an electrical blueprint or a plumbing drawing, you might not have certain features that you want to collect off of there because it's not needed on that specific type of drawing, right? So it might not have walls and door offsets. It might not have wall dimensions because it's primarily focused on things like light spacing for an electrical drawing. You know, and oftentimes that I know we've seen, I'm sure everybody who's worked with these types of as-built drawings, right? We hope they're as-built drawings, but it might not be what was actually constructed in the field. Things change over time. And then once they're produced, are we keeping them up to date as those changes occur? Walls are built, walls are taken down, for example. So we also want to just really consider that source and make sure that we have a really solid understanding of what we're capturing from those sources. I know I personally have worked on quite a few projects, and I've seen very large companies and other organizations undertake taking efforts to digitize, you know, paper blueprints, whether it's for just historical tracking purposes, or the end goal is to really build out a digital footprint of all of these indoor spaces. And I mean, I'm talking about in some cases drawers upon drawers upon drawers of these blueprints, you know, just stacked on top of each other. In some cases, no organization, you know, they weren't needed for what we're trying to use them for, as an example. And you know, that's very time consuming, right? To take that to get us to where we're trying to go. The varying quality of each of them is very different. Some are riddled with coffee stains. They're just not properly stored over time. They have rips, they have tears, they're faded. The information is hard to decipher at that point, right? But then again, you may have some that are in pristine condition. So really understanding the quality of that artifact is a really important step in helping us to make decisions on how to proceed as we're working towards, you know, the creation of indoor data. I also want to point out the resolution, right? Because geo-referencing isn't always 100% correct on the scale as you're doing it, but it's close. So keep that in mind as if you're undertaking an effort like this. Okay, so Matt's going to walk us through, you know, again, what I referenced earlier as this principles map. You know, as we've been working in that safety and security space quite a lot lately, we keep hearing folks reference, you know, principle maps, these maps that might be stuck up on the wall, for example, that were hand drawn for the purpose it needed to. Maybe it had hand drawn evacuation routes on it, or, you know, some other purpose where, you know, scale and measurability weren't super important for that specific point, but that's a source of indoor data, right? And so Matt's gonna talk us through some of those sources of information and considerations.
So Ashley mentioned earlier on the principles map, and really it comes down to everyone in this room is probably saying, well, who knows if I have this source data that's needed, and do I have it? Is it stained? Is our building from the 40s and it's changed 40 times and we don't know? So it really comes down to what the use case is. And for situational awareness, or for some general awareness, especially in like emergency response and public safety, things called principles maps or just even napkin sketches are a start. Getting the awareness of where do you need to enter the building? Is the gym on the northeast side or the south side if someone at the basketball game has an emergency? So you don't have to go all the way to 100% right away, but I think this highlights something that we talk about with standards a lot, is that needs to be documented. So if you have 100 buildings, you need to know what one was at maybe a SLAM LiDAR or a BIM standard that's very accurate, and what one was just hand referenced, and then realize the use cases, and maybe long-term be able to update the kind of the hand-drawn maps. But it's definitely a starting point that's very feasible for certain use cases.
Absolutely. All right, and our last source of data that we want to kind of talk through is when you have nothing. right? So where do I even start? You might be asking yourself that question. Where do I start? And in this case, boots on the ground, depending on the why, right? A theme we've been talking about. Why are you collecting this data in the first place? Why do you have a need for indoor mapping data? You can really collect that information when you have nothing in varying different ways. I'm just going to cover a few here, right? And again, based on that need, if you need really accurate measurements to accommodate, safe equipment navigation, then manual data collection is probably not the path forward that you want to go. That's not going to be the most efficient, and it's not going to be the accurate way to collect that information. But manual data collection might be an option if you just need to know where something's located in a building, or you just, want to start creating a spatial asset database or repository of all of the locations of, AEDs in a building, for example. That could be a great way to start. And there's tools out there to help you do that. So, tools like Esri Survey 123 is a great option. We have a couple partners that we work with that have some really creative ways to get in there and collect this information very quickly. And so, manual data collection is an option, obviously, depending on your purpose. As you need to get more detailed, more data-rich information, the ability to do measurements, right? You can move into like terrestrial laser scanners or mobile mapping systems with sensors for SLAM technology. So that's really helping to optimize our data collection. They'll help you create pretty quickly 3D point cloud data and panoramic images as you walk those spaces. So it's fast, it's comprehensive documentation for very large assets in complex environments like, factories, work sites, offices, etc. So our office, we have these wearable LiDAR units, and that's the picture there on the right as an example. It really is about 10 times faster than conventional scanning activities, and you're going to get out of that high resolution spherical imagery, which gives you automated alignment of walls, floors, and ceilings. And it helps us really reduce the processing time that it takes to generate this data and create that overall scene comprehension. So again, just to kind of recap here, right? When you have nothing, you can start somewhere, whether your purpose is, I just want to get in there and do some walkthroughs to create this data for manual data collection, all the way to getting really detailed, high accuracy measurement data that you can revisit over time to pull additional information out as well for different purposes in the future.
So we went over all the, not all, but a lot of the ones that we've identified as ingest data. But how do you consume this data? And I know there was a question early on in kind of the messages about the indoor mapping data format and in the exchange format that is, and then taking it to you can create the data in one format and then exchange it to go to other providers, Apple or Google or other indoor mapping providers. In the Esri data model format, there is also the indoors viewer, which is very tailored towards routing and hoteling and space management. But there's also other ways to consume this data. Your own personal organization's business cases can access the libraries of the runtime or the JavaScript API and make custom solutions particular to your organization. And I've seen organizations use this for everything from advertising to customers at a ski hill when they're indoors, to hospitals doing custom patient success forms. And then there's third-party indoors applications. And that's really organizations that have leveraged the runtime or JavaScript API or other programming mechanisms to display the either IMDF or the indoors data model for a specific industry solution, in providing those solutions with a very purpose-built kind of slant and angle to them. And so we've been exploring this option and doing this kind of in the public safety realm, really looking at how to display this data on a public safety first persona, because a very general indoors viewer might not help in the timely response of public safety with the buttons in the right locations and viewing the right data and the assets at the right time. And so there's multiple ways to consume this data based on each person's use case, and it's really extensible.
All right. So with respect to the considerations, we're going to consolidate and summarize those considerations when using these different data sources. Okay, so your level of accuracy is going to be very important. Make sure that you are not underdoing or overdoing your data collection in any capacity, right? Focus on that workflow and purpose first, and then understand the level of accuracy that's going to be required to meet those workflows and purpose of the outcome. Understand too that accuracy isn't the only, or accuracy is also including those areas of, how current is that data source, right? So the accuracy, not with respect to precision, but accuracy with respect to time. Is that data current? Can you verify it? Is your data source coming from a place where it is verifiable or easily verifiable? Also, make sure that understanding the complexity of the data is aligning with who will be consuming and using it. Most importantly, too, who's maintaining that data, right? So collecting information from a LiDAR source is going to be very complex and very, massive with respect to storage. We want to make sure that we do have systems and people in place that are going to be maintaining that data and tracking it as either your project or the use case evolves. Data volume and data complexity can expand into unprecedented territory if it's not kept in check. So to summarize here, we really want to keep the accuracy in direct alignment with your workflow, with your purpose, and with your people. So when collecting your data too, it's also important to make sure that you have the plans for how that data might or could be used in the future. Okay, so if you're collecting information about the AED placement in a particular school, also consider what is the outcome and the data collection, what it is that indoor mapping can be used for in the future. Speak to your clients, speak to your customers, or speak to your consumers of that data to make sure that you have the correct endpoint in sight about how you're going to be using this information. Data that is collected from a boots on the ground approach on a clipboard isn't necessarily as, isn't as easily scaled as information that's collected with 3D photogrammetry. We can place AEDs using 3D photogrammetry quite easily. We may spend a little bit more time on that upfront data collection, but in the future, we can couple that information with respect to other life-saving equipment. We could also use that information again with respect to facilities management or operations. Understand, like at the example I just used, there's no one size fits all. You can't use 3D photogrammetry for everything. You can't use LiDAR for everything, and you certainly can't use a boots on the ground approach for everything. So understand that with each solution that you select, you do have to have conversations about how that information will be used, not only in the present, but also in future applications. With standard, go ahead. Matt, do you want to start with this one, or do you want me to?
I can start with this one. I think what
it.
Jessica was saying and what we've iterated this whole time really comes down to the statement in this bottom corner: is accuracy and data metadata really matter. And what that means is, in any data model, especially at scale with multiple buildings, you need to know what what data is coming at what standard. So that one building could be at a really high level standard and one could be at a really low level standard, but serving completely different use cases. But when they're stored together, we need to make sure that there's not confusion on that. And really what that comes down to is scalability at the ingest, which comes from the BIM and the CAD standards. And there's a lot of good research on that. Some integrations that Esri already has into their data model, proving out, okay, if you get your CAD into a certain standard, it makes this process really easy and repeatable for things like nightly CAD syncs or BIM syncs. But also really makes it easy for a smaller organization to just easily do a one-time ingest or ingest for new projects. I know Jessica's talked about ISO 19650 and kind of it's really BIM standards, but it carries down into the geospatial work and really CAD on everything from project management to the structure of a project.
Awesome. All right, I know we have just a few minutes left. This is our last slide. We just want to have a call to action. So as we wrap up, we encourage and advocate that we as the geospatial community continues to create and or implement the standards that we've talked about throughout this presentation, or build new standards as we plan for the future and we break down silos, whether they're real or they're perceived. Start promoting indoor mapping efforts and data creation in your respective areas. Work with vendors to pilot new technologies or do it on your own and find new strategies for indoor mapping applications and data creation and maintenance. And as geospatial professionals, learn about BIM and CAD to share in those conversations and push to the future a shared effort with different uses of all of the same type of information. Understand what you're asking for, what you're receiving, and how to leverage that information. So with that, we want to thank everyone for spending this hour with us. I know we've been answering some questions in the chat along the way. Amy, I'll pass it back over to you, but thank you everyone for participating, and we'd love to continue the conversation.
Oops, sorry, guys. Thank you, Ashley, for that. And thank you, Ashley, Jessica, and Matthew for this wonderful presentation today. Unfortunately, we do not have time for additional Q&A. However, as you can see, they have their contact information and the slide. You can also reach out to me at info@nsgic.org to post your questions, and I will be happy to pass them along to the team. Otherwise, thank you all three again for this wonderful presentation. Any last words?
No, just want to say thank you to everybody. This has been a really great experience, and I hope to have more conversations with GIS professionals surrounding BIM and VDC data.
Absolutely.
Fantastic. Thank you.
Thanks, guys.
Thank you. And thank you, everyone, for attending today's webinar. Y'all have a great day.
Take care.